So in this problem, we have the following information. We have that a large chamber is separated into two compartments, 1 and 2, as shown, which are kept at different pressures. Now these are closed containers. These two containers are closed to the environment. So all the pressure, all the interactions in here are contained within these two containers. Pressure gauge A reads 0.3 megapascals, and this is gauge pressure. So this is the gauge pressure, and we have to remind ourselves that there's something very important when we're talking gauge pressure. Gauge pressure is equal to absolute pressure subtract the atmospheric pressure. And so the atmospheric pressure is whatever we have outside these two containers. So this gauge is designed to measure really a difference in pressure. It's really looking at the difference between the outside pressure and the inside pressure. So in fact, this gauge reading would change if the outside pressure dropped, because that would create a larger gap between the inner pressure and the outside pressure. So you have to keep that in mind when you're talking about gauge pressure. Gauge pressure is absolute minus atmosphere, or absolute pressure, the other way to look at that, is whatever your gauge pressure is with the pressure of the surrounding atmosphere added on top. So whenever you take a gauge reading, you have to add the actual atmospheric pressure on top to get a true pressure reading inside the container. So we're going to have to keep that in mind. Not only are we going to have to pay attention to this gauge pressure, but we're going to have to pay attention to the absolute pressure. So I'm just going to highlight a couple of things here that we're going to be computing. So let me just do this, get out my highlighter, and okay, so we know the pressure reading gauge A is known to be 0.3 megapascals. We also know that the local barometer, that is our atmospheric, that's our atmospheric pressure right there. That is our local barometer. So that's something outside this container. That's our atmospheric pressure. And so we're supposed to determine the absolute pressures existing in each compartment and the reading of gauge C in kilopascals. And then they want us to convert all these readings to atmospheres. Okay, so we've got a lot of things going on in this problem. So we're going to start just with apparatus A, so compartment A. So we have this pressure reading, and that pressure is really just due to the gas in here. That's what's influencing this gauge. And so we know that the pressure at A is reading 0.3 megapascals, but that's a gauge reading. So megapascals are 0.3 times 10 to the 6 pascals. All right, so that's easy enough to convert. That's the same as 300,000 pascals. Again, that's pressure at A, and that's a gauge pressure. So if we want to get the absolute, so the pressure at A absolute, we need to take the pressure at A that the gauge is reading and add to it the pressure of the atmosphere. Well, that was given to us. So we have our 300,000 pascals plus another 100,000 pascals again. Now you might say, where does that come from? Well, there is a conversion between bars and pascals. In fact, the definition of the bar, 1 bar is equal to 100,000 pascals. Okay, so what do we have now? We have just a simple total of 400,000 pascals, or 4 bars, if you will. Now they did want the reading, and this is the absolute reading, they did want that reading in kilopascals. Excuse me, I I stand corrected on that. They did want that reading in atmospheres. That was stated at the end of the problem. So you always have to pay close attention to that. What they want your final units to be in. So we need to convert these to atmospheres. Well, that's actually pretty easily done. So let's go back to this and do a conversion. So we have 4 bars or 400,000 pascals. So PA absolute is 400,000 pascals times, and the conversion is the following. 1 atmosphere is 101,325 pascals. So I will multiply that by 1 atmosphere per 101,325 pascals. All right, so if I put that through my calculator, I get the following. In fact, you might want to try this on your own. While I'm doing this, I'm not going to pause the video. I'm actually going to do this calculation. And when I get 400,000 divided by 101,325, I get 3.95. This is equal to 3.95 atmospheres. And that's absolute pressure. Obviously, if we want to gauge pressure, if we wanted the gauge pressure, we would just take 1 atmosphere off of that. So we take atmospheric pressure off of that. So the P gauge is equivalent to 2.95 atmospheres. Simple enough. Okay, so now let's think about what's going on in chamber B. I think it's pretty clear, and in fact, I probably should have said from the outset that it probably makes some sense to pause the video and see if you can figure out what to do next. In other words, if you can do the reasoning on this on your own, you can pause, work it out, and then come back and see if you can come up with the answer. So what do we have going on in chamber B? Well, we have to remind ourselves that the pressure in chamber A is pushing down on the surface of this mercury, and it's driving the mercury up in this tube. So in other words, the pressure in here must be greater than the pressure here. So we know the pressure in chamber A is higher than the pressure in chamber B. In fact, chamber B, to offset that pressure, to offset the pressure in chamber A, needs its own pressure plus this 900 milligrams of mercury, this column here, pushing down back on the surface that would be level with this level. So we've got this little extra weight on top of this surface here, plus the pressure pushing behind. So obviously the pressure in chamber B is lower than the pressure in chamber A. And we can probably reason it out that the pressure in chamber B is less than the pressure in chamber A by this little amount in here, whatever pressure this is created by this, because everything's in balance at that point. So if we can figure out the pressure created by this column of mercury, we should be able to go backwards to get the pressure in chamber B. So you may want to try that now before I give my solution. Just pause the video, give it a